Morning, everyone. I was told that this presentation may be distorted because I insisted on using my own laptop. So if you see any distortion, please blame it on me. But anyway, we'll talk about few things on battery safety and battery technology. So can we go to the next slide, please? Oh, this is the green one. Okay, great. So we've talked about a lot of things today in the panel discussion as well. There are a lot of engaging thoughts which we saw in terms of what are the challenges for electrification of our mobility sector. There is a demand side, there is a supply side issues, etc., etc. But I thought maybe we should talk about a very, very different thing which should be also very important for all of us, which is battery safety. I think a lot of the times we are talking about battery performance, we are talking about battery price. These are the two things which most of the people want to ask me whenever they realize that they are in front of someone who can talk about battery. They want to know the battery price and battery performance, etc. But really, safety is something which we are not talking too much about. Okay, so I just wanted to show you some visuals. Not sure if you guys have seen this. Oops. So actually there was a video. Can we try and play this video? Who is in charge of? So can you click? Is it possible to play the video? Okay. So this is available on YouTube for all of you to go back and see. What you saw in the background was that there was a small electric scooter. This is a video grab of a home in Beijing where a son and a father and a daughter and a dog, they just got saved. They were lucky that they could escape an accident by a vehicle charging. There are plenty of such, negative videos which one can see. And, we are all we also know there was a phone which exploded, and today we are not able to take some, we have to take a lot of precautions when we travel by air. So I'm not really trying to scare any of us that lithium ion batteries are unsafe or lithium ion batteries can cause hazards. But what I'm trying to bring up is a very, very important subject here, that lithium ion batteries, if not designed and handled properly, then they can be very, very dangerous. And we just saw one example here today in form of video. Now, this is something which a lot of people are, I believe personally, and then of course, we need to all have a discussion around in the industry that whenever we talk about batteries, whenever we talk about electric mobility, are we really paying enough attention to the safety of the batteries? Just for our understanding, I also want to tell you that 1 liter of diesel is equivalent of about 8.5 kilowatt hour of energy. So it's not really that diesel is more safe. Diesel carries far more energy in terms of weight per se, and we carry typically 30 to 40 liters, 50 liters of diesel in our cars, which is also potentially very, very dangerous compared to a lithium ion battery, even if we talk of a very large battery being in the boot of our car or in a scooter or a three-wheeler. The difference is only that how we are able to engineer the product, how we are able to engineer the usage of that product. So we have full faith today, barring few minor incidents which we see on the streets, we have full faith in the conventional fuel technologies of petrol, diesel, CNG, LPG, and variety of other fuels which we use. And that's where I think we need to understand that lithium-ion batteries can really, really be a big potential threat if not well understood, if not well engineered, if not well delivered. And that's where we need to take a pause and we need to start thinking about that what is our prime important thing. Is X dollars per kilowatt hour is the only driver we should look at, or we should look at safety and then some number of dollars per kilowatt hour, or a combination of these two is going to be very, very important. So that's where I wanted to build some sort of understanding amongst us and raise the level of importance of this. In terms of, so I'm going to talk a little bit about what could cause a problem in a battery, what could cause a kind of a hazard in a cell or a battery. So there could be certain external events, there could be certain internal events. Now external events, you can see very clearly that the ones which you see in the top three boxes is that, overcharge, external heat and external short circuit. And then there could be also internal short circuit. Internal short circuit is something which can happen because of not really having a well designed manufacturing facility. It could be because a foreign particle went inside the electrolyte or inside the cell. Now, how could one really manage these? And that's an engineering issue. That's an engineering issue, that's a manufacturing issue. One has to be very, very careful in terms of what kind of cell one is buying, because internal short circuits or internal faults which can happen inside the cell are really uncontrollable once they are manufactured. And they are very difficult to detect also for a variety of reasons, and they can just happen anytime. And we all know, there have been incidents where phone can blast, or a bike battery can blast, or a car battery can blast, and it can happen after a long time also. So these faults could be latent for a long, long time, and then they could just appear based on certain conditions, And so one has to be very, very careful in terms of what kind of cell one is using. Right? And then rest of the features, rest of the external faults could be managed by way of some external design in terms of how you charge your batteries, how you charge your cells. And some of the ways one can look at it is that there are three ways one can really look at it is that in the center you can see the protection by each cell. Each cell should have its own protection circuit, which means that even if there is a chance, a minimal chance of a internal short circuit or a foreign material going inside it, and some kind of a incident which might occur, the cell should be in a position to take care of it, which means that the cell should have its own protection to contain that fault which may occur inside the cell. And then obviously you will have to do protection in the module where you use multiple cells, and these protections would be with respect to overcharging, heating, and thermal management, and variety of other things. And then there should be also a system level communication strategy, that the system should communicate in such a way that there should be a detection of fault and containment of that fault. So I'll just show you some few examples how this kind of a situation is avoided in some of the well-designed batteries and cells. There is a anti-thermal propagation or flame containment strategy which one can use very easily. So each cell could have its own protection, but then in a battery pack there could be multiple cells, and if one single cell gets into a situation which is abnormal, then there should be a strategy, there should be a design which ensures that this fire or this incident doesn't propagate to other cells, because potentially one cell contained would be able to save your whole battery, and then you would not see such instances which we saw in the screen. One can also control charging voltage. So there is a lot of discussion which we hear, and more in terms of charging infrastructure. Everybody is focused on very quick charging and very quick charging. People are saying that we have to match the experience of fuel filling, petrol filling, the way it is done in 5 minutes or 10 minutes. So all the batteries should be charged very quickly. Now, obviously, that's an objective which is I would say very good objective to have. But at the same time, looking at the tropical conditions we have, the kind of temperature rises we see in our country, and the kind of chargers and the kind of other electronic products we see in our country, probably we need to take a pause again here and see that what is the most optimum way of charging. Because quick charging, fast charging is something which can really trigger this overcharge and overheat kind of a situation. And that's a very, very important thing. So I would say that one needs to be very, very careful again, and really take note of this, that charging control has to be really, really in a fashion that it is matching with the battery's capacity and the external conditions, which is very important. You have to also have clear traceability of each and every cell, because once there is a potential incident which happens, then one needs to be sure that this cell has to be traceable to the last pack where it has been used, so that there has to be a clarity in terms of which kind of cell, which batch of cells from the manufacturer standpoint went into which kind of packs, so that there is a clear mitigation strategy. And this is where, again, I would recommend a lot of people are buying cells from open market, from variety of sources, buying only on the basis of price. That's it. I would not name any of the companies or any of the geographies which are selling these kind of cells only on the price. Of course, we need good price, we need affordable price, but it can't be at the cost of not knowing what happened to us. It's an extremely, extremely important thing. So this is very important for us. And then obviously there are other local regulations with respect to safety. So whether it is AI standards and whether it is any other standard, one has to really go for those standards. Maybe I will not go into this because this is a checklist which is more technical, but basically what one should do at cell level, at module level, at variety of system levels. So this is something which, if somebody is interested, I could always share later. Now, talking about some of the other things that, this is something which is, again, everybody talks about it, that there are certain user adoption challenges which are linked with the battery capacity, battery's range, and range anxiety has been one of the key topics which has been debated for a long time, and people are expecting longer and longer range. Now, what is happening is that longer and longer range is expanding the size of the modules, which means that earlier a vehicle was using X and now it is using X into 1.5, which means that it is also increasing the demand of lithium-ion batteries and cells. Now, what is happening is, now this is a very interesting graph on the left side. If you see that in the year 2015, the global capacity of lithium-ion battery manufacturing used to be about 22 gigawatt hour kind of a capacity globally. If all the projections which we are talking today with respect to India, with respect to other markets, if they all come true, then what we are going to see is actually almost a exponential curve, and it's going to be something like 100 to 200 times of addition of capacity. Now, whether it is doable or not, we don't know, but it sounds very interesting, but at the same time, it poses a lot of challenges. You need to find resources, you need to find capital to do this, you need to find a lot of raw material to do this. So there are a lot of precious metals, I would call them, the rare earth materials which are required. One was talking about permanent magnets also for motors. Similarly, there is lithium, there is cobalt, there is so many other materials which are required, and they are going to be in high demand. At the same time, we have an objective of bringing down the prices. How are we going to meet that is a question which is going to be very, very difficult to answer today. And we have seen some of the trends. In last 2 years, cobalt prices have really gone up beyond anybody's imagination. And maybe there is still change happening which we are seeing today. In terms of battery design, especially for India, I would want to point out certain things. Very, very important things, apart from some of the very well-known understood facts of what is the drive range and what is the usage and what is the frequency of usage, is the tropical conditions and the shock conditions or the vibration conditions of Indian roads. One has to really be careful that this is an additional element of difficulty which our country poses when it comes to battery design. That the tropical conditions, because we never get a chance to cool off. When you are driving, it's heating. When you're charging, it's heating again. And at the same time, we are talking of a fast charging, which means that we are not allowing any time to really cool it down. And the road conditions really, really bring in very, very difficult situation where we are observing shocks and we are observing the vibrations which are never heard of in many of the other parts of the world. So this is very, very important for us to understand. Maybe I'll just skip this. This is not important. So something about future of the battery technology or the battery roadmap, as many people want to understand from us. And I thought maybe I would probably share some of it. This is not exhaustive. This is not really conclusive, but this is something which is, which is more about what is happening around the world. So what we are seeing is that there is lithium ion with silicon anode is being experimented a lot of the parts of the world, which is basically to reduce the cost by adding some materials which are widely available and increase the performance in terms of energy density. Then there is another thing which is happening across the world is called lithium sulfur. We all know sulfur is very easily available, but these are all again at the testing stages and at the laboratory stages. Then we are talking of lithium air batteries, which a lot of people are talking again, that lithium air batteries are going to be commonplace again, but I don't know when they will happen. And then we are talking of solid state batteries, which are again touted to be the next big thing. So I, what I wanted to show from this was that one of the issues which we saw, that there is a lot of demand which is going to have, which is going to put pressure on the availability of the resources like cobalts and variety of other materials. These are some of the strategies which a lot of global companies are trying to adopt to replace those with cheaper and more widely available materials, which are more locally available in variety of geographies. But at the same time, there is a word of caution that all these technologies at this point of time are still under development and testing phases, and it takes a lot of effort and time to really bring them out of the lab and to the commercial scale. So I think this is where I want to end, and if there is anything which I can clarify to any of you, I'll be more than glad.